This is a video on surface area. The question states, find the area of the part of the sphere of radius A over the circle of radius B for B less than A. So let's start by recalling that the surface area is the double integral over the region of the square root of 1 plus f sub x squared plus f sub y squared dA. So we need to find f sub x and f sub y, and we have a sphere as our surface. And the equation of a sphere of radius A is x squared plus y squared plus z squared is equal to a squared. I can solve for z and get that z is equal to the square root of a squared minus x squared minus y squared. There's no plus or minus because we're over the circle, not under it. So z is positive. So now I take some partial derivatives with respect to x and with respect to y. To take the partial derivative with respect to x, I use a chain rule. The partial derivative with respect to x of a squared minus x squared minus y squared is negative 2x. And the partial derivative with respect to x of the square root function is just 1 over 2 times the square root. So the 2 from the x squared becoming 2x, and the 2 from the square root that becomes 1 over 2 times the square root cancel. So I just get z sub x is negative x over the square root of a squared minus x squared minus y squared. Similarly, I need to get the partial derivative of the z with respect to y. And that's just negative y over the square root of a squared minus x squared minus y squared. You can notice a symmetry here. So now let's add 1 plus z sub x squared plus z sub y squared. And I get 1 plus, if we square these, the root cancels. I get an x squared on the top and a y squared on the top for this one, and they have the same denominator. So I can add them and write it as 1 plus x squared plus y squared over a squared minus x squared minus y squared. So now I can put this under a common denominator. A squared minus x squared minus y squared plus x squared plus y squared is just a squared. And I get that same denominator. So the next step is to look at the region, because I need to take a double integral over R. The region of the circle of radius B. When we have a circle, it's much easier to use polar coordinates. So I put my little man tilted like so. Notice the little man's feet are at 0, and the little man's head is at r equals b. And the angle goes from 0 all the way around to 2 pi. So I can put this information together and say that the surface area is equal to the integral from theta goes from 0 to 2 pi, from r goes from 0 to b, of a over the square root of a squared minus r squared. That's because we took the square root of this expression, and the square root of a squared is a, and a squared minus x squared minus y squared is a squared minus r squared. And dA was r dr d theta. So now I need to integrate this expression, and I use u substitution. If I let u equal a squared minus r squared, then du equals negative 2r dr. So here's the r, and I don't have a 2, so I need to multiply and divide by 2. So I get an over 2 outside. There's a negative. If we plug in 0 for r, we get a squared minus 0, or just a squared. And if we plug in b for r, we get a squared minus b squared. And then we have a root u on the bottom, and that becomes a u to the negative 1/2, du d theta. So now let's integrate. The integral of u to the negative 1/2 is 2 times root u. So the 2 and the over 2 out here cancel, and I get negative a times the integral from 0 to 2 pi of root u from a squared to a squared minus b squared d theta. And then I plug in. And also, the integral from 0 to 2 pi of, this is a constant with respect to theta, d theta, is just 2 pi. So I can pull out the 2 pi, and I can write negative 2 pi a. When I plug in a squared minus b squared, I get root a squared minus b squared. And when I plug in a squared, I get root a squared, so it's minus a. So finally, let's multiply the negative 2 pi a through. And also switch these around so I can get a positive in front. And I get the final answer is that the area of the part of the sphere of radius a over the circle of radius b is equal to 2 pi a squared minus 2 pi a times the square root of a squared minus b squared. And I'm done with the problem.